Hey guys, Mr. B here again, bringing you another awesome math video. This one on finding the slope of a line using the slope formula. So many of you guys probably learned in class that you can find the slope of a line using rise over run. So the symbol we use for slope is m. So m is equal to rise over run. Now this is useful for a situation like this where you have a line given. It works perfect. But there are other situations where you may not be given a line, or you just might prefer to do it this way, where you can use this formula. So rise over run is really the same as the change in y, so that's the up and down, the rise, over the change in x. That little triangle is delta, and that means change in. And of course, the change just means the difference between where you start and where you finish. So y2 subtract y1, all divided by x2 subtract x1, where x1, y1, and x2, y2 are just two different points on the line. So if you can see here on this graph, there are 2 points identified, and they're sort of baiting us to use those 2 points. So let's have a look at it. So that point right there is 3, 1. And this point up here is -1, 3. So it's asking me to find the slope of this line. So I could use rise over run for this, but I'm not going to. I'm going to use my slope formula. So what I usually like to do is just highlight and name my point. So I'm going to call this guy x1, y1, and this guy over here x2, y2, just like that. So let's go ahead now and solve this problem. So my slope is equal to y2 subtract y1, so my y2 is 3, my y1 is 1, all divided by x2, which is -1, and then subtract 3. So that leaves me with 3 subtract 1 is 2, -1 subtract 3 is -4. So -2 over, or 4 over -2 is the same as -1/2. And there it is. That's the slope of my line. So this part right here, that's really the same as your rise over run. So if you might have done it like this before, where you made a triangle and your run here, you could go down 2, so -2, and then 4, right? So your rise, -2 over 4. So mine's backwards, but again, you could have made your triangle on the other side and then right and down, or whatever it is you wanted to do. So it doesn't really matter the location of the negative, as long as you get the same answer, which you would get, -1 over 2. So that's how you use the slope formula. It's fairly straightforward, guys, and hopefully that little example helped. I'll show you a couple more now. So this one, very similar to the last one. We have a graph this time, but I chose this graph because there's no points given on the graph, so it's not really baiting us to do any particular thing. So we have to be really careful about which points we choose. It's even harder for me here looking at this computer screen as it might be for you guys doing this on a test. So if I look here, this looks like a pretty good point. And I'm going to try and find another one along here somewhere. This one all the way up here looks pretty good too. So they're far apart, but that's no big deal. I'm sure there's probably a couple more points. Like this one looks pretty good too. And so does this one, but it doesn't matter. Again, it doesn't really matter. So let's say those were the only 2 points. That would be a really big triangle to have to make. So this one question might be a little bit better done with the slope formula. So this is -8, and that looks like 7. And this guy over here is also 8, and that's -5. So again, I'll just label these x1 and y1, so it doesn't really matter which one's x1, which ones I could have had it reversed and called the other one x1, y1. Really doesn't matter. I usually try to look for what's going to give me the easiest numbers. I'll try to avoid any negatives if I can, but sometimes really you can't really help that stuff. Alright, so we got slope is equal to y2 subtract y1 all over x2 subtract x1. My y2 is negative 5. Subtract y1, which is 7, all over x2, which is 8. Subtract negative 8. So negative 5 subtract 7, that's negative 12, over 8. Subtract negative 8 is the same as 8 plus 8, so we get 16. So we get 12 over 16. Now both of these numbers are divisible by 4, so I can go ahead and do that. So if I divide this guy by 4, I get negative 3. If I divide this guy by 4, I get 4. So that gives me a slope of negative 3 over 4. So it's, that's what I really like about the slope formula, guys. It's pretty straightforward to use. All you need is 2 points. So another application of the slope formula is when you get a question like this. Determine the equation of a line through the points -1, 6, and 4, -8. So this is a really standard question when you're doing linear equation units in grade 10 or grade 9 or wherever you're doing it to. So it really, you have no other choice in this situation but to use the slope formula. So I'll write it out again, y2 minus y1 over x2 minus x1. And you end up in this situation. So this is, I'll just label this x1, y1, x2, y2, just like that. So y2 is 8, y1 is 6, x2 is 4, and x1 is -1. So watch your negatives here again. So that leaves me with 2 over 5. So that gives me my slope. So now I'm able to write the equation of a line. So it all depends on what equation of a line you're used to writing. The easiest equation of a line to write is slope point form. So I'll finish the question just for the sake of completeness. So slope point form looks like this. Y minus y1 is equal to slope x minus x1. Just like that. So y, I'll fill in. Doesn't matter which point I choose. I can choose this point. Don't be confused by the x1, y1. We could choose either one of these points. It doesn't matter. But I will choose this one because it's easier to choose if they're both positive. So my y in this case would be 8. My slope is 2 over 5. And my x is x, and my x1 will be 4. There you go. So there's the equation of my line in slope point form, which is really nice. So guys, I hope this video helped you using the slope formula. It's a really important concept in some early pre-calculus in grade 10 and grade 9. And good luck with your studies. And thanks for watching, and I'll see some of you guys in class. Thank you very much.